Hello there, I am S and this is S Solution. If you are into algorithms, you're preparing for an interview, or you are someone who enjoys critical thinking, do subscribe, like, share, and that will be very much appreciated. Now, so in the last two videos, we have talked about the staircase algorithm, where we could take one or two steps. And so instead of taking one or two steps, we are asked now that what if instead of being able to take one or two steps at a time, you could climb any number of sets of positive integers. So for example, you could climb either one or three or five times steps at a particular time. So it's still basically the same approach. So we will build on our recursion and try to come up with something. So if we check our previous is that there exists a staircase with n steps, and we could climb with one or two. Previously it was defined one or two, but now it could be anything. It could be just a number, it could be a set of numbers it will be given to us. So uh, let's look at how we could, let's go to the board and try and figure this out. So uh, we have here our 0, we have 1, but now it can be 1, 3 and 5, or 5 rather. Let's assume that the number we are going for is, let's say, 4. So at 1, you remember at every step we can either take 1 or 2 previously, so but at every point we can take 1, 3 or 5 in this scenario, since our array here is 1, 3, 5. So at this point 1, we could also either take 1, or we take 3, or we take 5. So that will give us uh, that will give us that will give us 2, 4, or 6, right? 6, but 6 is beyond 4, so we stop there. This could give us 3 plus 1 will be 4, 3 plus 3 is 6, is going beyond, 5 plus 3 is 8, is going beyond, 5 is already beyond, so that's the end for that. So 2, 1 plus, so this could be 3 or 5, 5 is beyond, or 7, 7 is also beyond. So this is already at 4, and there's no other. So we come here, this could be 4 or 6 or 8. So it means we only have 1, 2, 3. So let's look at it in the diagram and see. So let's so we have our staircase 1, 2, 3, 4. So we could either take 1, 1, 1, 1, yes, or we could take 1 and then 3, okay, or we could take 3 and 1. We can't use 5 anyway because 5 will already surpass 4. So we find out that we have 3 ways of uniquely going through that to that step in 1, 3 or 5 steps, taking 1, 3 or 5 steps at the same at any particular time. Okay, so let's so since we have this, so we know that at every point we can either take from the list that we are given. So if you remember in our previous, so we go over it recursively. So let's have another function. So function stairs count list. So let's call this is, so we are giving list. So we are giving the steps and we are giving the list. Okay, so stairs count list, and then let's say the steps is 4 and our list is 1, 3 and 5. Okay, so let's So we have this now. So you remember we are starting from so since we are going through recursively, function. So I don't know what we need yet. So we need to know if it has reached. So if if the step is equals to steps. Okay, so I'm sure we need step and step. That is, okay, let me show current step, and then we have the let's say total steps too. So that it's more explanatory. So the current step and the total steps. Okay, so if this is equals to 4, it means we know that we can return 1. Please, if this is looking confusing, I think you need to go to our previous 2 videos and watch so that you understand from where we're coming. Let me make this a little bit bigger. So if rather it is current step is greater than total steps, then we return 0. Okay, so we have our count, and we can say count is equals to, okay, so at this point now, the same, basically the same. We know that the current step is we take now, but you remember at this point we added for 1 and for 2. So if you check it, we added for 1 and for 2, but here we don't know what that number could be. It could be anything. In this case is 135. It could be longer than this, could be shorter than this. So how do we go through it? So I am thinking, okay, I have to go through that list. So I think I have to go through the list. So I will use a for loop for let I equals to 0, I less than the list. Okay, so I need the list here, list. Okay, so I need to go through the list, the length of the list. Okay, all right, so we go through the length of the list. So and so okay, so I want to add, okay, so recurse. Okay, so we will add the current step. So what is current? So current step plus what is our R in the list at this position. I think this should work. Okay, so since we are asking for total steps here and the list, so it will go for, so it will do for 1, it will do for 3, and it will add for 5. So when we add current step at 0, 0 plus 1, since list at 1 at position 1, position 0, sorry, is 1, so that is going to be current step 1. It will go for to the next, that is 0 plus 3, it will do for 3, and same thing for 5. And if, for instance, current step was 1, it will go to 1, 1 plus 1, it will do 2, 1 plus 3, it will do for 4, and it will do for 1 plus 5, which is 6. And then we know that if it is equals to 1, if it is equals to the steps, it will give us 1. If it's greater than steps, it will give us this. So, and we can return our count. I think this should work. It's basically the same as the last. It's just that this now, because the number of steps is dynamic, is no more as static as it was before. It was just 1 or 2, but now it's dynamic, and we can't predict what it is going to be until when it is given in the question. So we have to cater for that now, and that's why we're using a for loop. If the question said there are going to be only 2 items, then we will have just used, we don't need to use a for loop, because we will know that there will be 2 items. We just need to get the first and the second. But this question did not specify that there will be a certain number of items. So let's return. So we return, because we know we're starting from 0. We have the list. Okay, so 3. Wonderful. Okay, let's try for 135, and if it is 7, let's see. If it is 7, so that will bring us to our whiteboard. So if let's move this here, let's get this drawn. Okay, 1, 2, step 3, 4, 5, 6, 7. Okay, so we know for sure this is our ground point. So 1, so this definitely will work. This is one approach. Another will be, and this we have many. Okay, so we could have 1, we could have, I think this is going to be too many. Let's go for 5. Let's go for 5. Let's reduce this and go for 5. So that's 6. I think this is 5. So 1, 2, 3, 4, 5. Okay, so let's go. So this is 1, so we could go for 1, and then we'll go 3. Okay, we can't go 1, 1, 1. So if, so let's go. I think we can go, okay, we can go 1, then we go 3, then we go 1. Okay, what other approach do we have here? So let's, okay, so I could start with 3 2. So 3, then 1, 1. That is only possible combination I can have if I start with 3. And if I start with 5, then 5 goes all the way. So that is 1 2 3 4 5. Is that 5? 1 2 3 4 5. Yeah. Is there any other? Let me see. So if we start with 1, we will come here, 3, and 3 in return. Okay. Okay, so I think it's 5. So let's check and see if our algorithm is correct. So if we are going for step 5, wow, so we see that it works fine. But as usual, if we want to go for a bigger number, if we go for 40 now, we find out that it will. So let's try to fix that with memorization. So let's have our store, and if the current step is inside of our store object, then we know that it already exists, and so we return whatever is in the store in that position for that step. Okay, so before we return count, we know we are supposed to get update add the new step that we're just seeing for the first time. Okay, and then we know that here, wherever we're calling it now, we have to put our store there so that it can keep track of it. Okay, so let's see. If we put 40, so you see it's able to give us instantly. If we go as high as 400, it gets the value instantly, because memorization is keeping it simple for it, because what it actually will do, it will keep track of what it has done and ensure it doesn't do what was done already. So very efficient way of writing this program. I hope this was explanatory. Please, if you have any question on any of what we've done in the past on the staircase, please drop in the comment section, and I'll do my best to respond as soon as possible. uh, and also, if you're having challenge with any other matter, please feel free to drop comment in the comment section, and I will do my best to also respond, and any other person could also respond also. Thank you very much. And if you enjoyed this video, please like, share, and subscribe. And before I go, let me just say that nothing beats practice. So keep doing, keep digging, and you get better. Thank you. See you later.